Let's look at number 21 here in section 5.8. We're going to evaluate the following indefinite integral. And again, if you just say, well, let's try simple substitution, right? Let u be the 4 minus x squared under the radical here, right? Then my du is negative 2x dx, right? My derivative would be negative 2x dx, which I can, multiply by negative 1/2 and I'll get an x dx. The problem is I don't have x dx up here. I have x plus 4, right? Quantity dx. And so that 4 is problematic. On the other hand, you might say, well, hey, this kind of looks like, if I can get a 1 here, this kind of looks like the arcsine integral. Well, the problem is I've got this x up here. If it was just 4, I could pull the 4 out and I could do the integral with arcsine. So neither one of those techniques work on this entire integral. However, we did this in class before, right? We can split this up. We can break this integrand, the function we're integrating, into the sum of two separate functions and then integrate each one separately, right? So this fraction can be broken up into x over the square root of 4 minus x squared plus 4 over the square root of 4 minus x squared. This one on the left, simple substitution, u is 4 minus x squared, derivative negative 2x. I've got an x dx, and so I'm going to multiply both sides by negative 1/2. Negative 1/2 du is x dx. And now I can replace that. I'll pull the negative 1/2 out, and I'll have 1 over the square root of u. Remember, 1 over the square root of u is 1 over u to the 1/2, or u to the negative 1/2 power. So we find the antiderivative of this by the power rule, add 1 to a half. Dividing by a half is the same as multiplying by 2. And then cleaning this up, negative 1/2 times 2 is just negative 1. U again was 4 minus x squared to the 1/2 power means square root. I'm calling my constant C1. I'll explain why here in a minute. So there's the antiderivative of that one. And then this one is going to be the one that evaluates as arcsine. So if you remember, I need to get a 1 here in order for this to work. And so what I'm going to do, first of all, this 4 up here I can pull out as a constant multiple. And then I'm going to factor a 4 out of the two terms under the radical. How can I do that? Remember, factor out the 4. I'm left with 1 there. And then the x squared becomes what? X squared over 4. Because if I multiply this by 4, I'll be back to x squared. So now I can break up the radical of 4 times this stuff in parentheses this way, right? The square root of 4 times the square root of this stuff. Square root of 4 being 2. I can now pull the 2 out. Notice it is not 2, but 1/2, right? 4 times a half is 2. And now I'm almost there. I've got my 1 here. I just need this to be u squared. So I'm going to let u squared be x squared over 4, which means u is just what? The square root of this, or x over 2, which is 1/2 x. The derivative of 1/2 x is 1/2, so du is 1/2 dx. And multiplying both sides by 2 gives me dx is 2 du. So I'll replace dx with 2 du. The 2 can come out. 2 times 2 gives me 4 over what? Square root of 1 minus x squared over 4 is u squared. This is the integral that evaluates, right, as the arcsine function or sine inverse. Here's my constant. I'm calling it C2. And I just did that to simply state that these constants can be different. Replace u with x over 2, and we have 4 sine inverse x plus 2. And so our antiderivative becomes the sum, right, of these two antiderivatives. So this one plus this one, and then the C1 plus C2, I'm just going to combine into one constant I'll call C, and we do that. Again, usually we don't even worry about the C1s and C2s. Just at the end, in this case, make sure you include that constant. Okay, so breaking up is not hard to do in calculus. I hope this makes sense.